Now let's look at Perl. Perl is the standard regular expressions parser by which other tools are held. So oftentimes you'll see Perl compatible regular expressions or PCRE support within other applications because Perl has a long-standing history of defining the cutting edge surrounding regular expressions as well as other technologies. It's an all-purpose scripting language that's available on virtually all Linux systems. So its features include all-purpose scripting environment. So it does it all. Perl helped to popularize the dynamic web in the 1990s and up to the early 2000s with respect to CGI scripts. It was the major means of accessing content dynamically through the web. So you'd hit a website and perhaps fill out a form, and the action page would call a CGI script, which was really a Perl script for the most part, which performed the actions on behalf of the calling HTTP client and return results to the HTTP stream or back to the client from the server. So it's been the major gateway to the dynamic web and has been superseded in the web space with tools such as, or languages, environments such as PHP, Java, ASP, and otherwise. But it still remains the all-purpose scripting environment within NIX-based environments. And as a consequence, you'll find it everywhere on the system. And it has outstanding regular expression support. In fact, it is the standard bearer. Now on a system, if you do which Perl, you'll see it's in user bin, RPM query file, user bin Perl, and it's Perl 510 that is included with Red Hat Enterprise Linux version 6. So when writing Perl scripts, you'll use a shebang header of user bin Perl for Red Hat Enterprise Linux version 6. Some tasks for us include, but not limited to, of course, exploring Perl. Some of the things in which we may do within Perl. So for example, we can run scripts, simple scripts like hello world, or more complex scripts such as querying the system, connecting to a database, perhaps making a CGI request, and so on. Let's start off with something simple. How about just printing hello world? So we'll execute Perl with the E option. Now the E option, just like said, means commands are to follow. The commands will be specified between single quotes, and the commands take the form of standard Perl commands that are stored within a script. So meaning, if you have lines containing commands that end with semicolon, then you can specify them on the command line between the single quotes, including those semicolons. You may also specify multiple -E options to indicate multiple commands to be executed in succession or in the order in which they're presented. So to return hello world to the screen, we'll call the print function, and there are hundreds if not thousands of Perl functions that are documented. Just consult your local documentation using Perl doc, or followed by the -F with the function name, or consulting online perldoc.org to look up the functions that are available. But we'll just use some of the simple ones like printing hello world, for example. So let's print in between double quotes hello world and terminate with \n and a semicolon. \n sends a new line character. If you don't send a new line character, then Perl will print without or sans a new line character. So prints hello world to stdout or standard out. And this is from the command line. This is known as a Perl one-liner, a very simple one albeit, but nonetheless still a one-liner. Let's return to the shell and execute. Now if we drop the \n, notice that it prints hello world juxtaposed, and this should be within, so juxtaposed to our prompt, which is why we include the \n, so that there is a new line printed for the prompt to take advantage of. So you can print commands. Now, how about printing multiple commands? Well, when you write a Perl script, you normally separate your commands on separate lines, and lines terminate with semicolon, virtually all lines. So we'd simply perform as follows. Between the single quotes, just include that new line, such as another print command, such as print learning about the magic of Perl. And that would terminate another line with a new line character, double quote, semicolon. and that would print both lines for us. An optional way of printing these two lines is to indicate multiple -e commands. So for example, this is one command followed by another -e, which is a separate command. This would print both in succession similarly. You can also turn on warnings, something that is done within Perl as convention, so that if you forget to define a variable properly, for example, or make some other mistake that Perl could warn you about, it would take place from these one-liners. So you can run one-liners just as we've done here. You can set variables that we haven't done. Let's go ahead and set a variable, then print it, all from the command line. So B is to print two lines. Let's take this second invocation, which also includes the -w option, which prints warnings in the event that there is some sort of syntactical error with your code. Let's try this again. Control-Shift-C, Control-V, and now it's in place. So let's just put this all between single quotes so that it's understood to mean everything between is to be interpreted verbatim. So now variable setting, for example, in Perl is referenced using $ as the leading character, whereas $ within the regular expression world means, of course, at the end of the line or at the end of something. It also means the same in Perl regular expressions, but whenever $ is found on a line outside of regular expressions, / or delimiters, then it's understood to mean that it's the definition or declaration of a variable. So let's set a variable. So we'll be doing Perl E, and the first thing we'll do is set a variable. So fname equals Dino for my name. That's a variable. Let's set another one. lname equals Davis. And there are two variables that are set as we would within a script. Then we'll follow up with a print fname lname, followed by a trailing new line, followed by a semicolon, followed by a single quote. And let's turn on the warnings option in the event that we did something incorrectly. Now, normally you set variables using the my prefix, but not specifying the my is not a big deal. It just means the scope is broader. So let's clear screen and try this out. And indeed, Dino Davis printed with the warning options turned on. As mentioned, you can set variables with my, so let's go ahead and just localizes the scope, and this prevents misinterpolation in and out of conditional branches, loops, and so on. But nonetheless, it works the same way. So you can set variables, do all of this from the line, from the command line, and you can do even more complex things like initiate connections to databases, generate CGIs, and so on. So those are your Perl one-liners. Now, the art of using Perl, of course, is to write full-blown scripts that do things that are procedural, that have things that you need in them that are quite useful, that can take into account numerous variables and make them available, transform them, so on and so forth. So write simple script. Now this is being done ad hoc, so we've yet to come up with a purpose, but we'll play it by ear. Now, since we have an editor which understands Perl syntax, let's create a new document, and in it we'll reference our Perl script. Now, when writing Perl scripts, and this applies to any sort of shell script, whether it's Perl, PHP, Python, Ruby, you name it, if it is to execute from the Linux shell, you are to include or must include a shebang header. So let's just note all shell scripts should include a shebang header, i.e. one that's prefixed with a hash mark followed by an exclamation followed by the path to script engine, which in our case is Perl. So that means the shebang header will be user bin Perl. And again, from the shell, you can confirm that by doing which Perl. This will become our shebang header. So let's Control-Shift-C to copy it into memory and place it into our unsaved document. So hash mark exclamation user bin Perl. You can consult some of the scripts, the startup scripts, for example, to see examples of the shebang header. Let's take perhaps SSH for example. Here's an example of a shebang header. # exclamation bin bash. This means that when the script is executed, sans a prefix of a dot or the bash shell name itself, it is understood that the shell is to execute the bin bash binary to then process the script. So the shebang header instructs the shell on which interpreter is to process the contents of the script, since Linux and Unix systems support a wide variety of programming environments. So that's our shebang header. Following that, you indicate other options, such as use warnings, for example, or the optional -w at the end, which means the same thing, to turn on warnings. So I'll just include a hash mark, which means a comment, followed by perhaps declaration of variables and processing of your script. So what's important to us? Well, we've set some variables. My fname equals Dean. My lname equals Davis. And the same thing we did from the one-liner, so print fname, or perhaps change it around, lname, comma, fname with a terminating, let's include it in a separate string, terminating new line character. So print last name, first name. This is yet to be saved, so let's go ahead and just save this as a simple script, and that'll be Perl script 1.pl. Once saved with the pl suffix, then gedit colorizes it. Now, supposing there are errors in the script, before you execute any script, regardless of language, you should have the functionality or ability to check the script for syntactical correctness. With Perl, that's Perl-C. So let's just note, after you've created a script, so create simple script, and B, check for errors. We check for errors using Perl-C and the name of the script. This will check the script, as mentioned, for syntactical soundness. So that's Perl-C, and that's our script, Perl script 1. If it's returned OK, then it should execute. Doesn't mean all the logic's correct. It just means syntactically it's correct, which means lines end with semicolons, variables are properly labeled, and so on. Now, the next thing to do is ensure that the file is executable. So let's lsl *pl, and it is not by default. Files within Red Hat Linux by default are not flagged executable, so it needs to be flagged executable so that we can run it directly. Otherwise, we'll have to reference the Perl binary to run the script. So C flag script executable, and we'll do this with the chmod command, chmod +x, and the name of the script, Perl script 1.pl, simple script. This will make the script executable, and then we can confirm the permissions changes shortly thereafter. So let's change, and then when we're finished, lsl Perl script 1. So now it's executable. It's executable by everyone. That may or may not be desirable. You can always change that. For example, you can make it desirable, or you can make it executable by the desired person, for example. So chmod, perhaps O+X Perl, and lsl Perl script 1. That's everyone, and let's make it the user. And we actually made it everyone initially, so let's make it user, and or take it off and then put it back on. So let's go ahead and drop the executable altogether. So let's chmod, drop it, and then put it back on, and now it's executable by the owner, Linux CBT. So now we can execute this script, and it will process the variables. To execute a Perl script, just // which means the current directory followed by the name of the script, and then it processes accordingly, processing the variables. Now, if you make a syntactical error in the script, let's go ahead and generate some sort of error, such as leaving off the semicolon from the lname variable, for example. So now it's saved. Before executing it, let's Perl-C to determine whether or not the script is sound. Syntax error at Perl script 1 PL line 7 near print. had compilation errors. So the first thing that leads us to do is navigate to line 7. So 6, 7. Now this tells us that there's a problem between here or right before. Oftentimes compilers will return errors right ahead of the problem. So line 7 isn't where the problem is, it's before line 7. It's right here, semicolon. So, and other compilers will give you more accurate information, more useful information, but in this case, it's close enough. Now the syntax is intact. Now, what if we change the shebang header to, let's say, something like incorrectly Perl with 2 L's? How does that impact the -C? The -C doesn't check the shebang header to determine whether or not the binary that's referenced there is available on the system. It simply checks the syntax of your code to ensure that that's correct. So now let's recheck and we should be good. Let's execute. It'll run as we have expected. So now this is a simple script. Now what if we wanted to take input from the command line and print it accordingly as opposed to this hardwired stuff? Well, that's not a problem either. Every value that's presented on the command line is stored in an array named argv. So if we process argv, we'll be able to set our variables to the values of argv. So supposing that the first argv value is first name and the second is last name. So then by setting fname to argv, we can have that reference, for example, or just simply print argv0, argv1. So the way you reference array elements is to use the scalar $ notation. Scalar means single or single value. So we use $ to get to the single element of the array. Now, of course, an array means a list, meaning a number of items. But in scalar form, we're able to extract a single item from the array. When you run a script on a Linux system, regardless of the type of script, all of the values specified to the right of the script are included in that argv array. So a list is form of options. So let's say 0, 1, 2, 3, 4, 5, and so on. These values are all stored within the argv array. So argv0 will contain 0, argv1 will contain 1, and so on. And those items can be referenced throughout the processing of your script. And of course, it's on a per script, per session basis. So for each user, each session, each invocation, each shell. So if you opened 1,000 shells and executed this process 1,000 times, there would be 1,000 argv variables defined with their values. So let's reference argv and the element that's of interest. The way we indicate the element is by using square brackets after the name of the variable, the array variable, in scalar form. In array form, it's the @ symbol. That references the variable in array form. In scalar form, it's $. So this gets us argument value 0. And for last name, supposing it's argument value 1, so let's go ahead, argument value 1, and then let's check our script for syntactical correctness, and so far so good. That means we can try to run the script. Now let's see what it likes or doesn't like. Use of uninitialized value, lname, concatenation, line 8. So let's see what's going on with line 8. So it syntactically is correct, but it doesn't like the way things have been set. Let's take a look at what's happening here. Now normally when you reference variables, you protect the variables using quotes so that the contents can be expanded. So let's see if it's an expansion error. It probably is. Let's go ahead and Perl C to make sure, and then run it again. And now it reads use of uninitialized value argv, so it doesn't work. And in this case, makes perfect sense. Because look at the command line. We neglected to specify args, v's, 0, and 1. So we could have gotten away with the recent invocation, but let's try it now. It's throwing an error. That's expected because there is no argv0. There is no argv1 because we didn't supply them. There's a space, but a space doesn't constitute a variable. So let's specify the first name. So it's gotten the first name, and it doesn't have argv1, so let's specify the second value. Now 0 and 1 have been populated. But of course, this is poor scripting practice. We should have our environment set up in such a way such that the script catches or traps the neglected variables. So to do that, let's stretch this out again. We're doing this ad hoc, so we're just kind of stretching as we go along. In fact, this is the way I write a lot of scripts. Just as you go along, build it out. You have an overview, an overall idea of what you want to accomplish, but then you just build as you go. So if we use an if statement to test for the presence of argv, we can then trap whether or not the user has supplied any values. For each array variable in Perl, there's a way to get to the number of elements that are in the array, but its index is 0, so you're always counting down by 1. For example, if, and in between the if block, we specify $hash. This references the number of items that are in the array. argv. So if the number of items are less than, or the number is less than 1, for example, then chances are we have a problem. Let's see if 1 is the right value for us. So if it's less than 1, in fact, we can print it first to see what it is. So let's comment this out, and let's print command line args. And this will be printed as $hashmark argv, and we'll terminate with a new line. This will print the number of arguments presented on the command line, and it will tell us where we stand when we supply two options, if that's what's required. So notice command line arguments 1. That means it starts at 0. So if it's less than 1, we have a problem. In other words, this script requires 2 arguments. So if it's less than 1, we're on the right track. Then we have a problem. We need to alert the user that we can't run the script because we need more input. So in this instance, we will simply print to the user usage $0. $0 is the name of the script. First name, last name. And a new line. And we can also include the following. Please ensure that there are 2 arguments. And then terminate with a new line character. So this little if block will catch the error, it'll trap it and prevent, since this is procedural processing, the remainder of the code from executing, thus never presenting us with an error if the user supplies less than or fewer than 2 arguments. Let's Perl C to check the syntax to be sure that it's sound, and it is. Now let's run it, and it worked with 2. Now let's drop one of the arguments, and it doesn't work. So please ensure that there are 2 arguments, but notice that it's still attempted to go on in its procedural processing way, and that's because we didn't exit the script. So what we should do in this if block is exit with an error. Perhaps we'll specify an error of 35 to mean that not enough arguments were supplied. So in other words, before we specify this exit value here, or exit function, before we call the exit function, the most recent invocation continued to execute the remainder of the lines of the script, resulting in an error because not enough command line arguments were presented. Now we have the appropriate behavior. And if we echo the exit status, it's going to be 35. So usage, $0, the name of the script, the way it was executed. So $0 is a variable that's maintained by Perl to reflect the name of the script and the way it was invoked, so the full path to the script, followed by the 2 variables that are required. Please ensure that there are 2 arguments. Now, what if we ran the script absolutely? So home Linux CBT Perl script 1. Notice that $0 has been updated to reflect, and of course it'll work so long as we have access to the path, and so long as we provide the right number of arguments, it'll work. And then we can comment this because it's no longer needed, because we know argv is indexed at 0. So if you need 2 arguments, then you're checking up to 1. If you need 3 arguments, up to 2. 4 arguments, up to 3, and so on. So now this is set. It'll take argument values from the command line, and it will work accordingly. Now regular expressions work within Perl, as we've mentioned. For example, items presented on the command line can be compared against regular expressions, and you can perform branches or carry out branches in your code as a consequence of those matches. So here we have first name and last name, but we could then go on to say, well, tell me some more about fname last name. So if fname, for example, is regular expression equal tilde, we've used tilde in the awk section, now we're using equal tilde. This is the Perl way of saying if a variable is equal to a regular expression. And then the I option, which I turned on in awk but doesn't work by default in awk but works within Perl, is for case insensitive. So if first name matches, let's say, the following, this string, then let's do something about it. That something could be anything, such as printing, you are the right user. For example, this simply means that the fname supplied on the command line matches. And we could then further branch out else something, so on and so forth. And we can combine the matches here. If fname equals Dean and last name equals or last name equals, then do such and such. Let's see what happens. Let's check it syntactically. It's a simple regex check. Perl C, and let's go ahead and find that Perl C in our history. So the syntax is okay, and then let's run the script, and indeed, you are the right user. Now, of course, if we alter the first name, let's call the first name this way, Linux CBT, then it doesn't branch into the regular expression match, but it still performs the reordered print of last name followed by first name, but it doesn't branch into this area because this is a regular expression match. Any regular expression that's Perl compatible can be specified here and searched appropriately, and then you can branch out and perform as you'd like. Now, of course, Perl is much more powerful than we're showing here. This is just a simple way in which you may do things. You can execute processes, for example, and extract the output of those processes and do things with that output if you'd like, such as running PS and extracting. So for example, let's just come up with something ad hoc. So say you wanted to run a command system ps ef grep, let's look for a process that we would normally grep. So ps ef, let's grep all processes by Linux CBT. So we'll grep Linux CBT. This will dump the output to standard out after having executed it for us, and when we could then set all of this to a variable and parse it within Perl. So this is one way to run a process from Perl directly through the system. So this is just a psef grep Linux CBT, which could be all set to a variable or to an array. Then we could extract the elements in the array and process them accordingly. So it's a simple way to run a process. Let's Perl C. This should be in our history. And this will check for syntactical correctness. Now let's run the process. And there, this time when it runs, or ran, it did the psef for us, grepping Linux CBT. And perhaps we could then further awk and perhaps print column 1. And we have to be careful when running anything from the shell within a Perl script that we escape the characters appropriately, because otherwise Perl will attempt to interpolate the results and it'll break. Now it's worked because we escaped the $sign. So perhaps we print 1 followed by a delimiter. So let's go with hyphen, and perhaps we will skip the delimiter because that's going to make it a little bit more convoluted. And the $signs must be escaped, otherwise Perl will complain because it'll be looking to substitute those variables. So there's 1, 2, and 3. So you can run commands, and then again you can set this equivalent to a variable and then parse the variable if you like, and you can just comment it out if you're not using it. So again, Perl is a powerful tool. It allows us to string together myriad operations, literally myriad operations, including database, web, system, shell, you name it. You're able to interact with it using Perl. We've just looked at some simple ways in which we may execute. Again, you can execute from the shell using Perl E You may optionally specify a number of E commands or just string everything together between single quotes, so long as you keep track of your wrapping or enclosing single quotes and escape where necessary if you need to include embedded single quotes. Or you can simply just write a script and dump all of the items that you execute within that script. And if you do that, then procedurally Perl will process the script from top to bottom and carry out those items for you. Now again, there is a dedicated Linux CBT edition for Perl. It's Linux CBT Perl edition, so look into that if you want to study Perl extensively. Otherwise, this is just an intro so that when you see Perl scripts on your system, or if you need to write simple things or do simple things, you can do them on your system, such as simple Perl processes that perhaps you call with cron, that cron will wake up and execute for you. It could be anything, such as updating a log file, sending an email, so on and so forth.